13, 14, and 15 are really doing kind of the same thing, only we're using a percent mixture, and so we're going to be working with percentages. And again, you could use the substitution method, but I like the elimination method better, especially if I'm going to use my calculator. And so here I have a petroleum company has two different sources of crude oil. The first source provides crude oil that is 50% hydrocarbons. The second one provides crude oil that is 75% hydrocarbons. In order to obtain 120 gallons of crude oil that is 65%, how many gallons of crude oil must be used from each of the two sources? So, first source and second source, and we're again looking for how many gallons. So, we look there and we say, we want a total of 120 gallons. So I know that my first one plus my second one is 120. Now the rest comes from the percent. If I take 50% of the total number of gallons of first, I'm going to find how many hydrocarbons I have in that thing. So I'm going to use 50% of the first plus 75% of the second. And this is going to be where it's a little bit different, because I want to find the total amount of hydrocarbons. I have to do 65% of the total number of gallons. So I have to take the 65% of 120 to figure out how many hydrocarbons I had. Didn't say I ended up with so many hydrocarbons. It just says I have 65% of the total. So when I do this one, I'm first going to calculate this number right here. So 65% of 120. 0.65 times 120 is 78. So 0.50F plus 0.75S is going to equal 78 when I multiply that out. So now I've got that straightened out. Now I can go ahead and solve by the elimination method. Again, you can either get rid of the F's or the S's. I'm going to do the F's because the 50 is easier probably to work with than the 75. So I'm going to take everything in my top equation by a negative 50% so that I can eliminate my F's. So negative 0.50F minus 0.50S equals 50% of 120 would be minus 60 there. I've got opposites in front of my F's. I can go ahead and add those and cancel them out. 75% minus 50% would be 25% of the second. 78 minus 60 would be 18. So in order to solve that, I'm just going to go ahead and divide by my 25%. $18 divided by 0.25 is going to be 72. So S is 72. I've got 72 gallons from my second source. Again, in order to find the answer for the first one, I'm going to look at my two equations and say, oh yeah, that top one looks much easier to use than the bottom one. So I'm going to say F plus S equals 120. I know S is 72. So F plus 72 equals 120. And so all I have to do there is subtract 120 minus 72. And so 48 would be how many gallons of the first that I have. So again, if you wanted to check your answer, you're checking it here or in the red one here, because the red one is where we calculated 65%. But I would say, okay, if I want to check, if my first one is 50%, 50% of 48 would be 24 hydrocarbons. My second one is 75%. 75% of 72. I'm going to grab my calculator and figure that out. So 0.75 times 72 is 54. If I add those two together, my total number of hydrocarbons is the 78 I was supposed to have. Yep, checks out, works out good. Number 14, same kind of thing. The Royal Fruit Company produces two types of fruit drinks. The first type is 40% pure fruit juice. The second type is 90% pure fruit juice. The company is attempting to produce a fruit drink that contains 75% pure fruit juice. How many pints of each of the two existing types of drink must be used to make 150 pints of mixture that is 75% pure fruit juice? So I'm going to use T for tropical tangy and B for berry good. I don't really like the way they word that because they don't really say the tropical tangy is the first and the berry good is the second, but they imply that. So, how many pints of each? We can make a total of 150 pints of our mixture. So the tropical tangy plus the berry good must add up to 150 total pints. The first one is 40% pure fruit drink. So 40% of my tropical tangy. The second one is 90% of my berry good. And I'm going to end up with 75% of my 150 total pints. So I have to remember there, that first step, that I've got to take that 75% of 150 to finish up my equation. So 0.40T plus 0.90B is going to equal, and I'm going to figure out what 75% of 150 is. And I get 112.5. So now again, I can use my elimination method. I can get rid of the T's or the B's. I'm going to do the T's and use negative 0.40. And so I'm going to have negative 40% T minus 40% B equals, and then I've got to find the negative 40% times 150. So 150 times negative 0.40 is negative 60. I've got opposites in front of my T's. They're going to cancel out. 90% minus 40% would be 50%. And then I'm going to do 112.5 minus 60, which is 52.5. And then I'm going to divide that by 50%. And again, the calculators are active on word problems. I suggest you use your calculator just so you don't make a silly mistake on calculations. But if I take 52.5 and divide it by 50%, I get 105. So I have 105 pints of berry good. I need to find out how much tropical tangy. So again, I'm going to use the T plus B equals 150. I'm going to put 105 in for the berry good. So T plus 105 equals 150. And then all I have to do is subtract to solve. So if I take 150 and minus 105, I get 45. So I had 45 pints of tropical tangy and 105 pints of berry good. Number 15. A chef using a mixture of two brands of Italian dressing. The first brand contains 6% vinegar. The second contains 10% vinegar. The chef wants to make 320 milliliters of a dressing that is 7% vinegar. How much of each brand should she use? So we have our first plus our second. We're looking for how much. And it says the chef wants to make 320 milliliters. That's how much. So the first one plus the second one is that 320 milliliters of dressing that she wants to make. Says there that the first one contains 6% vinegar, so 0.06 F, 6%. The second one contains 10%, and they want to end up with 7% of their 320 milliliters of dressing. 7% vinegar, and we want to find out how much vinegar is there. So again, that's going to be our first step, is that we have to go ahead and figure out, well, what is that 7% of 320? So 6% F plus 10% S equals 0.07 times 320, 22.4. So again, we're going to use that elimination method, and we're going to go ahead and multiply that top equation by something. I'm going to go ahead and multiply the top equation by negative 10% because, again, that's easy to do. If you want to do the 6%, that works too. So negative 10% F minus 10% S equals negative 32. If I do 10% of 320, I just have to knock a 0 off of there, so that's why I used 10%. It was easy for me to do in my head. 6% minus 10% would be negative 4% F. The 10%s are going to cancel out. And so I'm going to take 22.4 minus 32. I get negative 9.6. In order to solve that, I'm just going to divide by my negative 4%, and a negative divided by a negative is going to give me a positive answer, so that's a good sign. So 9.6 divided by 4%, 240. So she used 240 milliliters of the first, right? The second one then, if I use my first equation up there, I know my first plus my second was 320. I know my first is 240 now. So 240 plus the second is 320. And if I subtract 320 minus 240 is 80. So 240 milliliters of the first one, 80 milliliters of the second one.